Today's lesson is on the difference between distance and displacement. You will remember from our previous video chat that distance is the amount traveled along a specific path, or how far an individual or an object traveled. Displacement, many of you may remember that word from 6th grade. You used it to calculate the volume of an irregular substance in a graduated cylinder. And you calculated how far the water had been displaced when you put the object in. We're going to talk something a little different today with displacement. So let's get started. We have a drawing here. We have what I'm going to call a block that somebody has run around. We have our individual, and he's going to start running from the center of the block. We're going to call this our reference point, which is going to be 0. On here, the black line represents the outline of the block. The blue line is going to represent the path that the student has taken. So we can look and see that our student has gone completely around the block and he didn't stop until he got back to 0. Notice that there are no arrows showing us which way he traveled. We can go this way or he can go this way. It does not matter. We also have put some measurements on here. We have 0 starting here, so then from here to this corner would be 30 meters. From this corner to this corner is 40 meters. From this corner to this corner would be 60 meters. From this corner to here is 40 meters. And then from this corner back to our starting position would be 30 meters. Okay? So take a look at this picture. How far do you think that the student has gone? You have a bunch of numbers you can calculate. Some of you may tell me that the student has traveled 200 meters. Some of you may tell me that the student has traveled 0 meters. In actuality, both of these answers are correct. But let's look at why both of them would be correct. So we have our same picture. Our individual, our reference point of 0. We have our same dimensions for our block, and we have the specific path that the individual has taken. Remember that we talked about distance, and that distance is how far an object traveled from one position to another along our specific path. Okay? So we can go in and start at 0 and note that he traveled 30 meters. So we're going to take 30. And then he traveled 40 meters, another 60 meters. He traveled another 40 meters, and then his last leg was 30 meters. We can add all of those up and we get a distance of 200 meters that our individual has traveled. So the distance that our student has gone is 200 meters. But now let's look at why the answer of 0 could possibly be correct. We have the exact same drawing one more time. We have the same dimensions. But now we're going to use a new definition. We're looking at the definition for displacement. And you should have a place on your note-taking document in order to write down this definition. Displacement is defined as how far an object is from its original position, regardless of the path that it took to get there. We usually state that when we're calculating displacement, it is the shortest path, which you know from math is a straight line, between the ending point and the starting point. So if we look at our individual, he started at 0, he ran around the block, and he ended at 0. So we can say that our student started at 0 meters, and he ended at 0 meters, and we can subtract those two and we get 0 meters. Think about this. When you get up in the morning, you wake up from your bed. We're going to say that your bed is going to be our reference point, and that's going to be our 0 point. You get up, you move around your house, you get on the bus, you come to school, you walk all through the school, you go home, you do a variety of different things, And then at the end of the day, you are back in your bed to go to sleep. You are ending your day in the bed. Your amount of displacement would be 0 because you started in your bed and you ended in your bed. But you traveled a great distance all day long. That's the difference between the word distance and displacement. So let's look at how would we calculate displacement. Remember that we said in our previous video chat that we were going to use x as a symbol for the word position. So we're going to use x with a subscript of 1, which is this little 1 here, and that's going to refer to our starting position. And we're going to use x2, which is going to refer to our ending position. Okay, so remember we said that displacement is how far an object is, which is how far an object is x2 from its original position, which is x1. So we can express displacement in an algebraic equation of x2 minus x1 is going to equal our displacement. So let's put this into practice with a different scenario. We have the same picture. We have same dimensions, somewhat. Notice though this time our runner has only traveled halfway around the block and stopped. We have our specific path in blue. We have our reference point here of 0. And I'll talk about this orange line in a minute. So we want to calculate the distance that he's traveled. The distance that he's traveled, we have him here starting at 0 going to the first corner, which is 30 meters. From this corner to the next corner, it's 40 meters. And then from this corner to this corner, it's 30 meters. So we can add those together and we get a total distance that our runner has traveled to get to here of 100 meters. If we want to look at the amount of displacement, which is from starting point to ending point, we're going to take the shortest path. And remember we said that the shortest path is a straight line from beginning to end. So we're going to draw a line here from here to here. We're going to take in place of a number value for our ending position. And we're going to use 40 meters instead of 30 meters. Anybody got a clue why? Well, when we look at this, our straight line here is equivalent to the distance here. It's not this. That's why we have to use the 40 meters. So our ending point is at 40 meters minus 0 meters where they started, which is going to give us a total displacement of 40 meters. Okay, please make sure that you have written this information on your note-taking document. We will be doing some more work with this in class, and I hope that you will understand it better.